All right, today I'm going to go over multiplying polynomials. Multiplying polynomials you guys have done before, but you've done really simple ones. Like the biggest ones we've probably done is a binomial times a binomial. So I'm going to show you more complex ones. If you can do these, then you've learned everything, okay? So the first thing that I'm going to show you is just a very basic one that you guys have done before. Something like I have 3x, which is a monomial, times x squared minus 6, which is a binomial. So you guys have done this before. You just distribute. So we get 3x to the third minus 18x. And that's your answer. And that's really simple. What we'll do to make it a little bit more complex now is we'll put something like negative 4c squared d to the third times 5c d squared plus 3c squared d. Now what you're going to do is you're going to multiply numbers together and same variables together. But it's still just distribution. So I'm going to do negative 4 times 5 is negative 20. C squared times c is c to the third. D to the third times d squared is d to the fifth. You're just adding the exponents when you're multiplying the same base. This is negative, this is positive, so it's going to be minus 12. C squared times c squared is going to be c to the fourth. D to the third times d is going to be d to the fourth. And that's it. So that's all you're doing when you're doing those guys. Now those are the really, really simple ones. What you're going to start seeing, which you might not have seen before, is something like this. So now I have a binomial times a trinomial. And what you've done before is a binomial times a binomial where you FOIL it. FOILing is just saying that you're multiplying everything in the first parentheses times everything in the second parentheses. And we want to follow that same process. So I'm going to do x times 3x squared, x times negative 6x, x times negative 4. 2y times 3x squared, 2y times negative 6x, 2y times negative 4. So I'm going to do this first. X times 3x squared is 3x to the third. X times negative 6x is negative 6x squared. X times negative 4 is negative 4x. 2y times 3x squared is going to be 6x squared y. 2y times negative 6 is going to be negative 12xy. And 2y times negative 4 is going to be minus 8y. Now I can't combine any terms because I don't have any like terms. But what you do want to do is you want to make sure that it's in this same order, where your exponents of just the first alphabetical variable come first, and then decreasing exponent for the combined variables. So since this is x to the third with no y, it comes first. X squared with no y comes second. X with no y comes third. Then you get the x squared with the y. This comes next. X with the y, this comes next, and then no x's comes last. And that's how you want to write it in standard form. I'm not going to be too picky about that, okay? We'll do another example where we have a trinomial times a trinomial. So the same process, you need to make sure that you multiply everything in the first parentheses times everything in the second parentheses. One way that people do this in order to remember is they write their first term times the second parentheses, plus keep the sign, the second term times the second parentheses again, plus keep the same sign, the third term times the second parentheses. You don't have to do it this way. Some people do this so that they're just distributing to one parentheses. So x to the third times 3x squared is going to be 3x to the fifth. X to the third times negative 4x is going to be negative 4x to the fourth. X to the third times negative 1 is going to be negative x to the third. And then we're going to distribute on this one as well. 2x squared times 3x squared is going to be plus 6x to the fourth. 2x squared times negative 4x is going to be minus 8x to the third. 2x squared times negative 1 is going to be negative 2x squared. And then we're going to distribute on this one. 2x squared times 3x is going to be plus 6x to the third. 2x times negative 4x is going to be minus 8x squared. And 2x times negative 1 is going to be minus 2x. Now I got to combine like terms. I only have one x to the fifth, so I'm going to write that first. And I'm going to cross it out. I have an x to the fourth here and an x to the fourth here. So negative 4x squared, or sorry, negative 4x to the fourth plus 6x to the fourth is going to be 2x to the fourth. And I'm just going to cross them out as I go so I know that I did them. I got an x to the third, an x to the third, and an x to the third. So negative 1 plus negative 8 means negative 9, plus 6 is negative 3. I have two x squareds here, so negative 2 minus 8 is going to be negative 10. And I only have one x, so that goes there. And that's your answer. So that's how you're doing those. You just need to make sure that you multiply everything in the first parentheses times everything in the second parentheses. You don't have to write it out like this. What you'll also see people do, what I'll see people do a lot of times, using the same problem, is they'll just go like this. X to the third times 3x squared is going to be 3x to the fifth. X to the third times negative 4x is going to be negative 4x to the fourth. X to the third times negative 1 is going to be negative x to the third. 2x squared times 3x squared is going to be 6x to the fourth. 2x squared times negative 4x is going to be negative 8x to the third. 2x squared times negative 1 is going to be negative 2x squared. 2x times 3x is going to be plus 6x to the third. 2x times negative 4 is going to be negative 8x squared. 2x times negative 1 is going to be negative 2x. You get the same answer when you do this, and then I'm going to combine like terms just like I did on the other one. So I get the exact same answer. It doesn't matter which way that I do it, it's going to give me the same answer. So you can pick the way that's easier for you. Okay? So we're getting the same answer each way. Okay. Now for the hard ones. Actually, for the hard ones, there's a special case, and I'm gonna do that on a separate video. Okay? So the problems from the beginning of this video used for the next video as well.